Hi guys, this is Mrs. Z coming to you from my living room. So today we talked about work, and later in this unit we're going to be talking about how work can be converted into energy. So today we're going to be talking about different forms of energy, specifically kinetic energy. I'm going to say hi, Rio. Come here. Say hi. Come here. No, can't see you. Rio wants to say hi. Hey, buddy. All right, so kinetic energy. Kinetic energy is the energy of an object due to its motion, so we use the notation Ke. It depends upon the speed and mass of the object. It's a scalar quantity, so it's not going to have direction, and you'll find that kinetic energy can only be positive because velocity is squared in this equation. And it's measured in joules, just like the work that we measured today. So the equation for kinetic energy is 1/2 mv squared, where m is the mass of the object in kilograms and v is the velocity in meters per second. So let's think about it for a second. With the equation Ke equals 1/2 mv squared, what would happen to the kinetic energy of an object if you doubled the mass? And what would happen to the kinetic energy if you doubled the velocity? So mass here, if we were to double the mass of the object, we'd end up doubling the kinetic energy. However, if we were to double the velocity of the object, because the v term is squared in this equation, we would end up quadrupling the kinetic energy of the object. So let's do an example. So a 7-kilogram bowling ball moves at 3 meters per second. How much kinetic energy does the bowling ball have? In addition, how fast must a 2.45-gram table tennis ball move in order to have the same kinetic energy as the bowling ball? So using this same kinetic energy equation, there we go, we'll do 1/2 times the 7 kilograms for the bowling ball times 3 meters per second squared, and we find the kinetic energy of the bowling ball to be 31.5 joules. So how fast would the table tennis ball have to move in order to have the same kinetic energy? So we'll use this same kinetic energy, 31.5 joules equals 1/2 mv squared. Now it's important to convert the mass into standard units. So 2.45 grams equals 0.00245 kilograms times v squared. Solving for the velocity, we find it to be 160.36 meters per second. Okay. So attempting a practice problem. If you had a 0.6 kilogram rubber ball with a speed of 2 meters per second at point A, and it has a kinetic energy of 7.5 joules at point B, determine the following. What would the kinetic energy of the ball be at point A? And then what would this ball's speed be at point B? Okay, so using our kinetic energy equation again, we put in 1/2 times 0.6 kilograms times 2 meters per second squared to find the kinetic energy to be 1.2 joules at point A. Then at point B, it says it has 7.5 joules of kinetic energy, same mass, 0.6 kilograms times v squared, and we find the velocity to be 5 meters per second. Okay, so I hope you have a good idea about how we calculate kinetic energy, what terms we use in calculating kinetic energy. So you'll have some practice with practice 5A, as well as some Khan Academy to practice these skills a little bit more. And then tomorrow we'll talk about another form of energy, potential energy.